Can everyone hear me okay? Is my microphone on? A little louder? Okay. I'm not in control over anything except how loud I talk, so I can just talk about this loud, and anything above that's going to get worse. All right, my name is James Prestwich. I'm the co-founder of Storage, which is a distributed object storage protocol. I'm currently the founder and CEO at Summa. We settled on the pronunciation Summa because if you say it the other way, it sounds like we're saying, I'm the CEO at some company or other. I don't really know. In between, I worked briefly with Bram at Chia, as well as on security audits at Least Authority. I'm an advisor at Keep Network, which is working on secure multi-party computation and verifiable random beacons. You'll notice I say a lot, so that's some concern was real. I'm not just making that up. You can find me on Twitter at _Prestwich, which is my last name. Before we get started, Tarek talked a little bit about Riemann. Riemann is a library that we released recently at Summa. It does transaction construction for 20 different blockchains. We support Bitcoin, Litecoin, Vertcoin, Decred, and everything else you've never heard of. Everything runs through the same interfaces. You can write your code once and instantly support 20 different mainnet blockchains, real cryptocurrencies out there. Your apps go from supporting one currency to supporting 20 overnight. And we will try to support Chia by the time it launches. We're already prepped for Zcash's network upgrade, and we maintain it so you don't have to. All right, so we're going to talk a lot about Bitcoin transactions, Bitcoin script, and so we should probably have a quick refresher on script and blockchain time. So I can't really remember what my slides are here, so I'm just going to kind of launch into it. So I actually don't have any slides. Perfect. Script is a simple stack-based language for Bitcoin transactions. The way Bitcoin works is you lock it with a program, and if you can provide inputs to that program that work, you can spend the money. That's what all Bitcoin addresses are, is little programs written in script. And time on blockchains is a little wibbly-wobbly. It usually moves forward, but sometimes goes sideways or backwards. Generally speaking, after 11 blocks, you know it's moved forwards. We don't have to worry about that, except in as much as it affects some of what we work on with cross-chain contracts. When we're working on two different blockchains, we have to deal with two different time systems that are moving at different rates and might be going backwards relative to each other. And frankly, that's a little weird most of the time. So for cross-chain contracts, we use a very important primitive. It's called the hash time lock contract. So this is a very simple Bitcoin script written in script that has two paths. You can see them between the if, the else, and the end if. The first path is Bob knows some secret and reveals it and gets the money. The second path is Alice waits and gets the money. Waits for some preset time to pass. So we can really abbreviate all that script as something much more human readable, Bob in secret or Alice in time, right? So to make a cross-chain contract, we put one of these on each chain and flip who's doing what. So in this case, Bob knows the secret. Bob starts off with that. And we set up on Bitcoin, if Alice knows the secret, which she doesn't at the start, she gets the money. She gets Bob's Bitcoin. Or Bob can wait for a refund, right? So after Bob funds that, Alice knows that she can get the money within a specific amount of time if she learns the secret. So Alice on Zcash funds the exact same contract in reverse. If Bob reveals the secret, he can get the Zcash. If he doesn't, Alice gets her Zcash back after a certain amount of time. You can see that the time for Alice is a little shorter, so we know there's a window where Alice can get a refund and Bob can't. That's how we keep it safe. There's no situation where Bob can refund his Bitcoin and get Alice's Zcash. So this is what it kind of looks like in practice. For setup, Bob's going to make a secret, And we're going to make these on-chain contracts. Ooh, shouldn't have moved the mouse. There we go. So we pay into these contracts on each chain. Bob locks up his Bitcoin first. Alice locks up her Zcash second. Then Bob, when he wants to, gets the Zcash, and Alice gets the Bitcoin. She looks at the Zcash transaction on chain, sees the secret, and uses it to get the Bitcoin. So she goes back to her, Alice plus secret route on Bitcoin to get the Bitcoin. So here's kind of a timeline of it. We have this time period, 5 hours, where Bob can choose to exchange his Bitcoin for her Zcash. From hour 5 to 6, Bob can't do that without losing money. Alice is completely locked up. She has no optionality here. And after hour 5, if Bob hasn't taken her money, she has to refund. And anytime you see this word must in all caps, it means that's something they have to do or they lose all of their money right away. So if Alice doesn't refund between hours 5 and 6, Bob can refund his Bitcoin and get Alice's Zcash. So over time, we've gone from this position where Bob can exchange his Bitcoin to, if he hasn't, Alice gets her Zcash back, then Bob gets his Bitcoin back. In the middle, they're locked up on chain, and neither person can move or spend their money, which kind of sucks. I don't want to be in a trade with you if it means that I have to be online and illiquid all afternoon, sitting in front of my computer, hitting refresh on a block explorer. These aren't really very good for decentralized exchange. When you go on a Forex exchange and you trade dollars for pounds, you don't expect it to take 6 hours, 2 transaction fees per person, and just be kind of a mess. So they're slow. And the other thing is, because Bob chooses when this happens, Bob's actually getting a better deal out of this. Bob de-risks his position because he has the option to get Alice's Zcash or his own Bitcoin back. So he gets to watch the market in the meantime and decide if this is still a good trade. So he gets basically 5 hours of free arbitrage at Alice's expense, which is no fun. So let's fix it real quick. We'll do a cross-chain atomic call option. And we'll just, this is basically the same setup. We just increased the duration real quick. Like, you might say that's cheating. We just changed it from 6 hours to 6 months. We didn't actually change anything about the contract. But we actually did improve it this way. Now, instead of 6 hours lockup, everybody's locked up for 6 months. Instead of Bob getting free options off of Alice, Bob can pay for the service. This is now a built-in feature. Optionality is a feature. Latency is a feature now. When we deal with contracts in the 6-month time frame, everything gets a little more fun and practical. These get useful for people who want to hedge risk across time instead of just exchange currency. The cross-chain atomic transaction is better as a hedge than as an exchange. So it has the exact same procedure. It's just everything takes a little longer, 6 months instead of 6 hours. But Bob gets to hedge risk. Alice gets returns because Bob will pay for the service of reducing his risk. And we don't have any black swan timing events with like wibbly-wobbly on-chain time. Over 6 months, all of that averages out because proof of work difficulty adjustment's kind of amazing. So right away, we know that longer duration solves a lot of the problems. So let's make a few more variations on this. Let's make a mandatory version where Bob can not choose when it happens, where he can't back out, where he doesn't get a refund, where they have to exchange. So here's a simple mandatory version. We're going to pay in basically the same way, where this time it's Bob's Zcash and Alice's Bitcoin, because I was lazy making these slides and didn't want to revise. So Bob funds the Zcash and has 2 hours to withdraw it. He gets a refund if he acts within the first 2 hours. This is a feature of Zcash that Bitcoin doesn't have, by the way. So Bob funds the Zcash. After 2 hours, he can get it. Within 2 hours, he can get it back. After 3 hours, it's Alice's. There's a 1-hour gap in the middle. And on the Bitcoin side, Alice puts up Bitcoin. At any time, if Bob refunds, Alice gets to refund. Okay? Or after 3 hours, the Bitcoin belongs to Bob. So it's a very similar procedure. We lock up one side, we lock up the other side, and then they both settle. In the failure case, if Alice never funds, Bob gets a refund right away, very quick. We know it failed within 2 hours instead of waiting 6 hours to see. And in terms of time, Bob has a refund window at the beginning, but once that's passed, they're both locked in. They both have to exchange. There's no optionality. There's no passing of risk anymore. So we can use very similar HTLC-based constructions to adjust the terms of this cross-chain contract. I have one more, much more complicated example for this. Does anyone have questions before we get any further? Yes.
The K in that diagram was the secret, it's a key? Is that
Yes, the K is a secret. I just kind of abstracted it because it's much quicker to type K than secret. Yes?
Just a heads up, the mics are on, stand behind the lectern, we can hear you.
Okay, don't stand behind the lectern. Got it.
You got it.
How did you come up with this explosive method?
With this one, I sat down with a notebook and a pen and kind of tried 12 things until it worked. It's a little interesting because Zcash and Ethereum can support transaction expiry, but Bitcoin can't natively. So this contract is actually limited in what chains can be on each side. Most of these things are completely generalizable across chains, but not this one. The right side of this equation has to be Zcash or Ethereum. Yes?
So the whole custodian of money issue, how?
So everything is done in on-chain contracts. There's no custody issues because everything is enforced by the rules of the chain. When Bob locks up his Bitcoin or Alice locks up her Zcash, they're putting it in programs that run on-chain that enforce these terms.
So Alice and Bob have they actually have, they're the owners of the money.
Right.
And so it is not they're not going through an exchange. And
Right. So these are.
So this is not as if they are on Coinbase or.
Yeah, these are completely bilateral, so just between me and you.
Okay.
They're atomic, so there's no way that I can end up with all of your money there's no way I can end up with all the money or you could end up with all the money as long as everyone does their job right. And they're trustless in that we don't have to know each other or trust each other at all. There's no way for me to scam you or vice versa as long as we follow the rules.
And is there an interface or is this just this?
So
That's what he's selling.
yeah, so we actually do have a fully fledged UI for these things. Right now we support options pretty well and we're working on adding a few more things. I'm not demoing that tonight. It's not quite demoable. Yes, Ryan.
Is the DVP for the 6-month option also atomic?
One more time, sorry.
Is the delivery versus payment of the 6-month option also atomic?
So these are not like cash settled options. We're physically settling this.
No.
Okay, sorry. Oh, yeah. Yes, paying the premium.
Yeah.
Yeah, the premium can also be atomic. It's an extra setup step. So you increase transactional complexity, but you can still make it atomic. You could also do the premium payment after the contract or in the middle of the contract atomically. It can get a little painful, and I'm not prioritizing that right now.
So what are the pairs? So
So-
there's set pairs, obviously, the then?
Well, we're not making a marketplace, and like I was just talking about, we have a library that supports 20 different cryptocurrencies,
Okay.
plus Ethereum, plus all other ERC20 tokens.
So people can make their own pairs?
Yeah, so it's a bilateral contract, whatever pair you and I agree to set.
Okay.
Yes.
So can you sell your position as the option holder to someone else?
Can you sell your position to someone else? Not now, but in about 3 months, yes. So on the Bitcoin side, we need to add, on Solidity it's easy, we can tokenize the positions. On the Bitcoin side, we need to add in a few more script terms and a little extra transactional complexity. So I think it takes 2 extra transactions to sell a interest, one on each chain. Yes?
Hey, Stephen.
Yeah.
Have you thought about structuring? I'm getting a lot of interest for this. Just to throw it out there, the ability to sell the upside on a coin as a part of a way to hedge without having to put extra money to hedge the downside. By giving up the upside like people do with insurance contracts. For example, they'll banks buy it for 60 years, and then they give the upside above 8% and they guarantee no downside.
Yeah.
Are you thinking about doing that?
So I have thought about that a lot. That's really outside the scope of this talk, but you can do it trustlessly on Ethereum with smart contracts. Yes.
What's the opcode?
So it's actually not an opcode. It is a transaction expiry. It's a field in overwinter transactions. And so you actually have to do a little run around with several pre-signed Zcash transactions to do this properly. It's kind of painful right now, so we're supporting Ethereum in the first version for this specific one.
So how are you managing security laws around,
Securities laws?
yes, around, because they have to do with the whole money servicing?
These are more on the derivatives side of things, so we're not doing these right now. This is more of like CFTC stuff than SEC stuff. These are derivatives, not securities. So right now we're not doing it until we get something worked out there. Yes?
What about multi-parties? So sort of at least you have 10 people?
Yes, can do. We can even do like 10 people on 10 different chains versus 7 people on 3 different chains.
And there is no distinction between Bitcoin and Ethereum? So you can do it with both?
We can do it with both. And it stays atomic, trustless, and all on-chain. Yes?
So you did mention that like this transaction is kind of unique because it's Bitcoin and Zcash. Can you like just go over that again?
Sure. So this specific construction relies on transaction expiry, which is a feature that Solidity in Ethereum and Zcash's new transaction format support, but Bitcoin does not. So this side of the contract, where it says less than 2 hours, has to be on a chain that supports expiry. All right. So we're going to move on from here. I hope that was helpful for understanding this. The main goal of all of this stuff is to build, two-party contracts that are mutually enforceable. Things where we can trade between us with no third party involved, and we can, hedge each other, we can exchange currencies, and we can do it all atomically and trustlessly. So, all right, we're skipping through this. So what if I have liquidity concerns? What if I don't want to put up my Bitcoin the entire duration of the contract, be that 6 months or 8 months? I might want to spend it on something in 3 months, or wind up, hedging it against something else, or using it in some other contract. In a traditional market, you don't have to put up the dollars as collateral to buy an option. You just pay the premium, and then you have the right. So there's a few different ways around this, and I'm going to cover one of the easier ones, which is, well, you have to be locked up, but we can give you an escape hatch. So we can make an option across chains that is atomically cancelable. So we have the option contract from earlier where Bob gets to decide whether exchange happens. In this case, Bob gets to decide whether exchange happens or whether the option gets canceled and everybody gets their money back immediately. All right? And so we have a few modifications to our scripts. So on Bob's side with Bitcoin, there are 3 different ways to spend the money. Either Bob knows a cancellation secret that Alice starts with, Bob starts off not knowing it, or Alice learns the exercise secret that Bob starts with. So they each start with one secret that does different things. Or Bob waits 6 months. And on the Zcash side, we have it with Alice and Bob in a multi-sig, so just a straight up 2 of 2. Or Bob reveals the secret that he starts with. Or Alice waits about 6 months. So you might notice that the bottom 2 rows of this are the standard option contract. It's only the top row that's different. So what we're going to do to make it cancelable is we're going to first take away Bob's ability to get the Zcash. Second, refund Alice's Zcash. And third, refund Bob's Bitcoin. And the way we're going to do that is via a pre-signed cancellation transaction. So this gets created and signed by Alice before the contract executes. So that Alice and Bob in multisig in the top right is going to sign a transaction that pays that Zcash to, look, I made slides to do the breakdown that I just did. I need to trust myself and just move on for the slides. Anyways, so we're going to pay from that multisig route in that script in a pre-signed transaction that's not on chain yet. Okay? So Alice signs it, gives it to Bob. He holds on to it until he wants to cancel. And what this cancellation transaction does is it moves it from the script on the left, which is our cancelable option script, to the script on the right. And what the script on the right does is give Alice the ability to get her money out within 12 hours. After 12 hours, it gives Bob her money. So she has to do it within 12 hours or she will lose all her money. And to do it, she must reveal the cancellation secret, right? So Alice must refund and reveal a secret, or Bob gets her money after 12 hours. And Bob decides when this cancellation process starts. So here's the happy path. It looks just like the normal option. We lock up the Bitcoin, we lock up the Zcash. Bob takes the Zcash, Alice gets the Bitcoin. That's what happens if it's exercised. Okay? Then this is the cancellation process. Bob locks up the Bitcoin, Alice locks up the Zcash. When Bob wants to cancel, he moves the Zcash. Oh, I messed up my settlement. He moves the Zcash to the cancellation script, and Alice refunds from there. When Alice refunds, it reveals the cancellation secret, which lets Bob refund. So here's the cancellation. This is if the option expires. We have it just like the normal option. This is the exercise path. Bob claims the money, and then Alice claims the Bitcoin. And this is the cancellation path. Bob gets the right to exercise or cancel. Alice is locked up. When Bob cancels the option, Alice must refund her money. When Alice does that, Bob gets his money back too. So this can happen at any point during the 6-month contract. So this means that Bob, as the holder of the option, doesn't have to be illiquid for the whole duration. If he needs his money back, he can get it. He has the right to cancel. He does this with a pre-signed transaction that changes the terms of the existing contract. All right, so that's what I have to share today. This is really a lot to digest all at once, and the cross-chain stuff is a little difficult, so we'll do a lot more questions in a minute. And we can go back over anything until you feel comfortable with it. I try to keep these short so that we can do more Q&A. But we are working on a lot more than this. So here's a teaser for the future. And those boxes are supposed to be unicorns, and the rainbows are supposed to be in color. But I guess emoji don't like me today. So, all right. We've talked a little bit about Solidity here. I phrase everything in terms of Bitcoin and UTXOs because they're much more restrictive, and anything we design for Bitcoin we can do in Solidity. And turns out we can also do a lot more in Solidity if you trust Ethereum, which people use it. So what about an Ethereum token with hash-locked issuance rights? So this gives Bob the right to issue tokens by paying Bitcoin. We can do that with the exact same option structure, but instead of getting Zcash, he makes new tokens. We can have hash-locked rights to any Ethereum contract, so we can always make a Solidity contract whose execution is contingent on me paying Bitcoin, right? So we can do cross-chain messaging in a very simple way that way. I think that token issuance is one of the more interesting ones because of how much money people are spending on tokens right now. Like really unreasonable amounts of money. And once we get into Solidity land, we can do some other magic things, like instead of Bob putting up the money up front, what if Bob didn't put up the money at all until he wanted to exercise the option? And when he wants to exercise the option, he will provide in Solidity to an Ethereum contract an SPV proof that he paid Bitcoin recently, right? So in a Solidity contract, we can validate a Bitcoin block header or multiple Bitcoin block headers. We can validate a Merkle tree proving that a specific transaction was included in those headers. And then we can validate the script that was paid to by a transaction. And we can prove that Bob paid to the option script in Bitcoin within a Solidity contract. So then he doesn't have to put up the Bitcoin at all until he wants to exercise the option. So there's a lot more interesting and new things we can do with these basic primitives and contracts when we mix in Solidity, when we mix in Stellar, and when we mix in all of these other chains' unique features. I'm not a one-chain developer here. I don't think we end up in a one-chain world. We're trying to build cool stuff for every chain and every interaction between chains. All right, more questions? Yes?
Can you please elaborate on how you actually verify block headers in the Solidity contract?
So Bitcoin block headers follow a very particular format, but the only thing we care about is the proof of work. So we verify that they present a header of the appropriate length, and that the Merkle tree for the Merkle root, which is embedded in the header, contains as a leaf node some transaction that pays to a specific, creates a specific UTXO. As long as the headers contain enough accumulated work, we know that either they are part of Bitcoin's main chain, or someone just spent $20 million to mess with us. And in either case, we're kind of fine with it. As long as we're not risking $20 million on this, which honestly I don't think we should be on any single transaction right now. Yes?
The cancellation transaction?
Yes.
The second output was Bob after 12 hours.
So the cancellation script.
Right, the cancellation script. Is that just to incentivize Alice to produce the secret?
Yes, that is to force Alice to allow the cancellation, or she loses her Zcash, and then Bob gets his Bitcoin back after 6 months. So if Alice does not cooperate with the cancellation, she loses everything. Yes, Bren.
So when you're doing cross-chain time intervals of 6 months, with a delta of 6 hours on that actually matters, you're not using block height there. You're stuck with timestamp.
You can use block height if you assume that everything averages out to like 95% of the expected block interval because proof of work's going up all the time. But probably better to use timestamps because most chains, they're pretty reliable with...
Because your delta on the very first one was a less than 5% skew.
Yes. Yeah. Parameterizing that is difficult and is a really fun statistics problem. Yes.
So when you're paying the Ethereum smart contract, then how do you factor in the cost of changing gas prices?
So when we're paying into a Solidity contract, how do we factor in gas prices? For a lot of these things, we're solving that for the near future by making the contracts fairly large, where gas is negligible. Gas is always paid by whoever submits a transaction. So it's up to whoever is currently calling the contract to set a reasonable gas price and to pay the gas. Yes?
Yeah, thanks. On the issue of how to avoid locking up the money for the two parties, understood that if we assume we have solidity, there's ideas like the STB proof that you talked about.
Yes.
What if we assume we don't have solidity? Do you have any ideas of how to do it in like pure Bitcoin to avoid locking up that money?
So there are constructions in Bitcoin not to avoid locking up the money, but to make the locked up money, the rights to that money, tradable. And so that's what I would pursue first. I don't know if there's a way to do it in pure Bitcoin without locking up money, but we can make it a little more liquid.
You could do it like the guys at Go Abra do. They actually make a contract and put or a get on the financial system against that, so you could bet against or bet for it. And that contract has liquid value. It's in like 23 countries.
Right.
It gets around the money laundering rules.
So Abra does essentially pool user risk and enter into an offsetting position. I'm trying to do all of this without a central party managing it, without a central party enforcing the terms of the contract. And I don't know if there's a reasonable way to pool risk without a central party to manage it. Yes?
I have a very naive question. So if this is a truly decentralized exchange, Bob and Alice, they have to exchange a secret at some point. How do they meet? Like, where do they actually, do they monitor blockchain for this type of contracts? Like, how do they find each other?
So we're making contracts, we're not making like an exchange or a marketplace. We think that that solution will show up once we'll build it once these work and there's enough interest in them. So right now, Alice and Bob basically have to know each other in real life and agree on the terms of this contract.
Right.
They never have to exchange a secret, or they never have to exchange something that stays secret. All of the communication in this could be done on-chain if we wanted to. They have to exchange public keys and the hashes of secrets, but they never have to exchange anything that's non-public.
But they should be aware that they exist.
Yes, they need to be aware of each other and they need to be communicating. So maybe at first this looks like known people at funds talking to each other on the phone. Maybe it just looks like me and some guy on IRC playing with it. We're still in the setup and contract instantiation phase. We're not trying to jump straight to a DEX or a marketplace for this.
So how would you build a central order book?
How would I build a central order book for it? It's possible to... I haven't fleshed this out, but I think it's possible that a central order book could cache partially constructed transactions. But that's getting into a... Yeah, the other way to do it is just to have a central order book that introduces people and say, if you guys don't trade, I'm docking your accounts or something. That's easy. Yes, Bram?
Can all of the secret reveals here be hidden from the blockchain if you have aggregatable signatures?
Potentially, yes. But you'd need both chains to support aggregatable signatures, most likely. If you want all of the revelation to be hidden from the blockchain. Or you'd need Taproot or something.
Is it possible actually to clear this decentralized? Somebody's got to enforce the contract besides just the technical part. Because we all know at some point someone's going to find a hole to exploit it. That's why I like the one thing that Abra's approach that I do like is they create an ecosystem where there's incentivized for more people to actually give people money and sell out or take money out and take the risk.
Yeah.
So you're really just decentralizing the risk and then incentivizing what people are doing anyway to save when the exchanges get hit themselves. So maybe that's a way you can operationalize that and reward those who enforce that for you en masse.
Yeah, potentially. I think that there's a lot of opportunities for central businesses to provide value around these contracts. One of the reasons that we keep it so simple here is to so that we can be sure there aren't any exploitable holes. As long as Alice and Bob stay online for these constructions, they won't lose their money. And they can, between the two of them, enforce the terms of the contract. Yes?
You mentioned this can handle multi-parties on either side.
Yeah.
How do you handle cancellation if one party wants to?
Oh, that's a really fun problem, which I haven't fleshed out a full answer to yet. The basic constructions can just do it natively. In fact, you can enter into and modify the terms of existing contracts just by making more on-chain transactions. So we could increase the amount of BTC on one time at a specific time if we wanted to, but I think that there are ways, but I have not done a lot of research there. Yes?
Have you introduced the token economy into this model yet, or no?
So I think I mentioned earlier about the token economy that when we're in Ethereum, we can tokenize the rights and obligations of these contracts. So, for example, when I lock up Ethereum as part of this contract, I can create a token that represents the right to that Ethereum. And whoever holds that token gets the Ethereum paid out to them when the contract resolves. So, hypothetically, you have a token whose price tracks Bitcoin because the market prices it based on their confidence that that option will or won't be exercised, right? So the market should price that token to reflect the current, BTC in Ether exchange rate and the movements of that rate. Yes?
You thought about some of the possibilities that open up with something like Lightning where everything is off-chain. Of course you have.
Yeah. So my main concern is Lightning can do really fast swaps, really great. When we get into longer dated contracts, you can't attach something to this to a Lightning channel without blocking the channel. So I don't want to block channels for 6 months. But what we can do is anytime we see a multi-sig in any one of these contracts, or anything resembling a multi-sig, or anytime we see a single signature, we could replace it with a multi-sig. All of those can be opened as Lightning channels. A Lightning channel is just a structure that builds a couple unsigned or signed off-chain transactions off of a multi-sig. Any Bitcoin that's locked up for these contracts could be opened as a Lightning channel, similar to Ethereum tokens, trading the rights to that Bitcoin. Lightning is asset agnostic once you get past that it's written for Bitcoin, but that is a very long way off. Yes?
In some of the examples, technically one of the owners, Bob or Alice, has ownership over their locked token and also the token of the other person before the cancellation is enacted. Is there any type of risk condition that could happen with sending the cancellation and then canceling the cancellation because they're also still in possession of tokens at that point?
So they're not actually in possession of both tokens. The tokens are locked up in scripts that enforce specific terms, right? And so when we build these scripts, we set the timeouts such that that can't happen. So this is why Alice's timeout is slightly shorter than Bob's timeout, is so that there is no race condition. We know the order in which things will happen. This is what Bram was talking about earlier with wibbly-wobbliness of time on chain, is we need to pick durations for each side of this contract that minimize the probability that they will happen in the wrong order. Yes?
Yeah, just related to that. And I think in your first example, it was 5 hours on one side and 6 on the other.
Yeah.
Does that mean if on one side or the other there's no block for an hour?
Yeah, so 5 hours and 6 hours is not very safe. 2 hours and 3 hours also not very safe. But the mandatory is a little safer than the optional version because there's a no action period. But basically we need those to be long enough that randomness in the chains like that averages out, so that even if there's not a block for an hour, the contract still works. This is why we probably want it to be timestamp instead of block height for all of this stuff.
Sorry,
Yes.
just a very quick follow-up. When you say the timestamp, that's the timestamp of the block, not the transaction, right?
Yes, the timestamp of the block. And timestamps, well, okay, it's actually a little more complex than that. In Bitcoin, sorry, let's back up. In Zcash, it's the timestamp of the block. In Bitcoin and most other chains, it's the median timestamp of the previous 11 blocks. So that ensures that it moves monotonically instead of going forwards and backwards like in Zcash. Bitcoin block timestamps can still go forwards and backwards, but we don't use them to measure time. Yes?
Sounds like I need cross-chain block timestamp insurance of some sort.
I can make that.
Yeah, I was just thinking about it.
Yeah. I have a spec for difficulty derivatives, and we could use that to do timestamp insurance. Yes?
Maybe, well, it is a little more chain specific, but there's something like Zcash no input add more flexibility, like the fact that you can kick time forward?
Yes. It definitely adds a lot more flexibility, and I haven't figured out what I'm going to do with it yet. But also I don't expect it to be merged or active for at least 2 years, so not a pressing concern. Yes?
If Alice and Bob are total strangers, besides the exchange rate, what is the absolute least amount of information they need to directly send each other? Like a transaction ID from Alice to Bob, and that's it? Everything else is...
Yeah, not a transaction ID. You don't even actually need the transaction ID. So what Bob and Alice need to communicate to each other is one pub key per person per chain, and then the hash of the secret. They also need to communicate the terms of the contract, which is which assets, how much of each asset, and what the duration is. But, one pub key hash each plus the secret. So the way I have it set up in practice right now is Bob will communicate 2 pub key hashes and the secret hash to Alice, and Alice will communicate back 2 pub key hashes.
But if the script is, presumably it's a data script hash,
yeah,
you wouldn't know that your pub key is in there.
Yes, because once you have all 4 pub key hashes and the secret hash, you can independently derive both script hash addresses. Yes?
How much discussion is there going on about like a decentralized P2P layer to communicate these types of things?
Not a lot. I don't worry about it. It's not in my roadmap at all. I think that this community disproportionately focuses on marketplaces when we're not even close to ready for them. P2P exchange is really, really hard and provides very few advantages over centralized exchange. No offense, Brandon. So I'm building contracts and ways for me and you to trade. We'll build out marketplaces on top of that later, once we know if these are actually viable.
So the business layer is really providing that communication, or the business aspect is providing that communication layer.
For now.
But you allow the option to take that out of your business, which is
Yep.
what you want to do, I guess.
And also, anything in crypto that's on chain is replicable, so it's not really defensible to keep my IP secret. I think that most of the value proposition of a business like this comes out of the relationships. Tech is replicable, relationships aren't. Any other?
So does it mean that you basically keep one of your IP?
One more time, sorry?
I mean, do you keep most of your IPO chain, basically, is what it's like? Everything is open source, everything is open?
It's not all open right now. Once it's a little more polished, it's all going to be open. And like for all of this stuff, once it's on chain, it's open source and anyone can recreate it. You can't keep anything on chain a secret. Yes, Brian.
So slightly out there, for the situations where you need something to expire at a certain time.
Yes.
You could potentially build that by having something where the counterparty can spend it in less than that amount. They can spend it after that time and they can yank it out.
Yes. So you can expire things. This is the way to do it in Bitcoin, which doesn't support expiry natively, by creating a set of pre-signed transactions with other inputs that are time-locked. So you need to create one time-locked input per script path you want to expire, and pre-sign one transaction per expiring script path. It's painful, but it's totally doable.
And they can be arbitrarily small inputs.
Yes, they can be arbitrarily small inputs as long as they're above dust limit, which is actually not that small right now, strangely. It's still less than a penny. Don't worry about it. Yes?
Also, naive question. Do you need anything more than basic Bitcoin script? Let's say you have 2 Bitcoin blockchains, like Bitcoin Cash and Bitcoin. Can you do that? Or you need something else?
So for the only thing that needs something else is the mandatory exchange. That needs a chain that supports expiry. Everything else I've shown can be done with just Bitcoin. Bitcoin to Litecoin or Bitcoin to Bitcoin Cash. This one requires one of the chains to have a malleability fix because it requires a pre-signed transaction. Let's see. For Bitcoin to Bitcoin Cash, one of the other fun things I made last year was a design for a fork future. So a contract we could enter into now that would trade my Bitcoin for your Segwit 2x coin after the fork. Never got to see the light of day, unfortunately. But these things are possible. We can arbitrage chain forks. We can make contracts that we instantiate before a fork that take effect after. We can move between just Bitcoin-like chains pretty easily. Yes?
Will Chia scripts support the expiry natively?
I am not sure if Chia transactions are going to support expiry natively. No? Great. A lot of people don't like expiry as a concept because it makes the transactions less safe in reorgs. Because if the height of the chain changes drastically in a reorg, your transaction with an expiry time might have been valid on one fork but invalid on the other, which means that you could accidentally double spend your coins with transaction expiry. So Zcash has decided they accept this risk. Ethereum just kind of gets it by default because Solidity and shared state are kind of scary and terrible sometimes. But Bitcoin, Chia, and a bunch of others, I don't think will ever have that feature. Yes?
Do you have a document for people who are working on new blockchain technology as to which operations they should support to make these things interoperable?
Support what Bitcoin script supports. Yeah. Anything you add on top of that is like bonus value add, as long as you're careful about it. Don't do things like what what Bitcoin Cash is doing with op group ID or whatever it's called. They haven't done it yet.
There's a lot of argument about it.
There's a lot of argument about it, but it's a terrible idea, and you can quote me on that. All right, any other questions? Are we good? We good?
Does everybody want to take a break? Maybe
I could use a break.
For a while? Or are you guys good?